Hello everyone. The next question we are going to take is unique binary search trees. I have solved this question 4 months back. Okay, let's try to solve it again. Unique binary search trees. So we can see, given an integer n, return the number of structurally unique BSTs. Okay, structurally unique BSTs. Okay, so if this is 1, 2, 3. Okay, so we have to really determine the shape that it could be possible, the shapes it can come up with. Okay, and nodes should be exactly 1 to n. Okay, okay, yeah, and the constant is 19. So we are gonna do some kind of recursion. What I can think of is, let's suppose n is equal to 3. Okay, so if n is equal to 3, initially what we are gonna do, we will put our root as 1, we will put our root as 2, we will put our root as 3. Okay, so what are the um, candidates for its left subtree? Nothing, no one, because nothing is less than 1, because BST's left subtree, all the element in the left subtree are less than root. Okay, and when we check for the right, the candidates are 2 and 3. Okay, how many the possible values? Okay, the possible trees using 2 3 are 2 3 and 3 2. Okay, so now we are gonna call our recursion on this, and the result given by this and the result given by this will be multiplied to get the our final result. Okay, we can do this. So our recursion is okay. We are gonna get our left part. This is root. We are gonna get our left and right, then multiply it and it sum it to uh, changing our this root. Okay, and we have to do this recursively on every node. And our base case will be if not root, not. Instead we should do like, if we don't have any, if we can't create any root, okay, then return 0. uh will it work? Not return 0, instead return 1. Okay, return 1 because we are multiplying and then summing up. Okay, yeah, if there's nothing we can put in left, then return 1. If we can't put anything in right, then also return 1. Okay, we will see while coding. Okay, let's try to code this question. Okay, so let us suppose, and do we need to use dp somewhere? Yes, if we have calculated value for our node, then why to calculate it for again? So if, yeah, so if we have a node, okay, if we have already calculated for a range, then we are not gonna calculate for it again. uh yeah, let's call our function define. Okay, count trees, something like this. Now, or let's make a helper function, like helper. We are passing the current root, not root, the minimum possible and the maximum possible, 1 and n. Okay, so for I in range, okay, 1 will be our start. Start is equal to 1 and the end will be n. And what is n? N is passed inside it, so let's keep it as end. Let's take it as started, and we are gonna call our helper function on start and end. Okay, and returning, and we'll return it too. So start will be our 0 and end is our n. Sorry, start will be our 1 and end is our n. Okay, for I in range 1 comma n plus 1. Yeah, 1 comma n plus 1. It will take 1 to n. Okay, the current root will become our 1. So if we have our something like result, this is our result, then do something like this: result plus equal to call helper function from start to I, sorry. Okay. I mean, making left and right, like adding the left possible subtrees, number of left possible subtrees into number of subtrees possible in the right, and that will be, second, control V, it will be from I, not I, instead I minus 1. Okay, and here it will be I plus 1 comma end. Yeah, this will work. So okay, and initially res is 0, and at the end return res. But now we have to take our base cases. That is really important. So what could be our base case? If start is equal to end, something like this. Or if start is greater than end. If start is equal to end, let's suppose. Okay. Then yeah. So let's dry run a code. That's how we will be able to figure out the real constants. Sorry. So now let's take it. So let's take on n is equal to 3, or rather 4. Let's take it on 4. So let's take it on 3. Okay. So we have 1, 2, and 3. The first we are going to use 1. Left will be called on 1 comma minus 1. So it will return me 1. And this will be called on 2 comma 3. Okay. Then further, okay, this is happening on 1. The same will happen for 2. Left will be get called on 1 and 1 minus 1 or something else. One second. This is 1 and 1. This will be called on 3 and 3. Okay. It will return 1. It will return 1. So if yeah, if start is less than equal to, no, sorry, if start is greater than equal to end, then only return 1. Yeah, this will work, and else return 0. Till now code is looking smooth. Let's run and debug it, because it might give some, we can miss some corner cases in here. Okay. Yeah, so what we are doing is, instead of calling on 1 second, I called it on I minus 1, I called it on I plus 1 every time. Okay. Or if start minus end is, okay, so let's put one more thing. If start, if start not, if end minus start is equal to 1, then return 2. So, I mean, the idea is simple. If you will write pseudocode, it will work fine. But now we have to, okay, yeah, it is working on 3. But the important thing is to find the value, to find the corner cases. Yeah, so, okay, it is working fine, but we have to use default dict. I mean, we are going to use DP. So through memoization from collections, import the default dict. Yeah, it already reached the limit. Okay, so let's do memo is equal to default dict of int. So if this start comma end, couple of it is in memo, then return memo of this start comma end. Okay, let's return it. Else count the value and put it inside res equals res. Now run the code. Still we can, I guess we can get some maximum depth reached. Okay, yeah. So the problem is start is greater than equal to end. Every time is, I don't know what's happening. Let's put a start and end for print start comma end. It might help us. Okay, fast row. Leetcode is 1610. Okay, 10. Every time it is printing 20 and 26. It is recursively calling on 20 and 26. Mm, let us suppose if it is called on 20, it get called on 20 and start is greater than equal to int, then 1 is returned. Okay, I'm calling it on left and right. Start to I minus 1, helper of I plus 1 to end. Okay, and initially our start is 1 and end is n. Okay, everything looks fine. So the time now, so it's 13 minutes, so no big deal. Start and end is there, start and in memo, then return start comma end, else it got updated. And every time, oh, why are we using n in here? It should be end. Yeah, this is the problem. We have to start, we have to start from start and end to end. Oh, okay. Yeah, this is working fine now. So that was a typo, or I would say instead of typo, yeah, it was a typo, but I will also include into a silly mistake. And now it will work fine and it will get submitted, I guess. Let's try it on something else like 12. And okay, n is equal to 1. If n is equal to 1, what will it return? N is equal to 1. Yeah, it is accepting. So let's submit it. Yeah, it got submitted. Okay, guys. Uh, thank you. So subscribe for more questions. We will meet soon. Bye.